Why do minor environmental factors impact electrical measurements? Imagine trying to measure something very tiny, like a whisper in a noisy room. Small environmental changes can make a big difference in electrical measurements. When we talk about calibrating test equipment or measuring electrical signals, stability is key. But even tiny shifts in temperature, humidity, pressure, or electromagnetic interference can throw off those measurements. Temperature is one of the biggest factors. When it gets warmer, the resistance of metals changes because of thermal expansion and how electrons move. This means a resistor or sensor might give a different reading just because of temperature changes. Electronic parts like resistors, capacitors, or semiconductors also react to temperature shifts, causing the measurement to drift or become less accurate. If we don't account for temperature, our results can be off by a significant margin. Humidity is another factor that impacts measurements. High humidity can cause moisture to get into sensitive parts, reducing insulation resistance and creating leakage currents. This can lead to false readings or noise in the data. On the other hand, very dry air can build static electricity, which can interfere with delicate electronic circuits. Both situations can cause errors that make measurements unreliable. Pressure changes are less obvious but still important. When measuring gases or using sensors sensitive to mechanical stress, atmospheric pressure shifts can alter the results. For example, a sensor that measures gas volume might give different readings if the air pressure changes. Mechanical sensors like strain gauges or load cells can also be affected by pressure or vibrations, causing slight deviations in their output. Electromagnetic interference is another common culprit. Nearby magnetic fields or electrical noise can induce unwanted signals in measurement devices. This can distort readings or cause fluctuations that aren't related to what you are trying to measure. Light exposure can also influence optical sensors or photodiodes used in some measurement setups, leading to inaccuracies. In the world of electrical engineering, calibration is all about adjusting for these tiny environmental effects. During calibration, engineers often use temperature compensation algorithms or perform calibration in controlled environments like temperature-stabilized rooms. They also add protective measures such as shields or barriers to block humidity or electromagnetic interference. Without these precautions, small environmental fluctuations can add up over time, causing errors that reduce the precision of measurements. When designing measurement systems, engineers must consider these factors from the start. Using sensors with built-in temperature compensation, maintaining stable environments, or protecting equipment from humidity and electromagnetic noise helps keep measurements accurate. For example, in resistance measurements, keeping the environment temperature steady or using sensors with temperature compensation improves results. In fieldwork, protective enclosures and environmental monitoring help reduce the impact of changing conditions. To sum up, minor environmental factors impact electrical measurements because they change how materials and components behave physically and electrically. Proper calibration and environmental controls are essential to keep measurements reliable and precise. This way, engineers can trust their data, even when conditions aren't perfect.